In the previous video, we took a look at how you might prepare a solution from a solid, where you would weigh the mass, and then you could determine the number of moles, and then you would eventually determine the concentration or volume, depending on what you're looking for. Well, here we have a way to determine the concentration or volume or number of moles of a new solution that's prepared from what we call a stock solution. So a stock solution is one that has been pre-prepared for you, where you know the concentration. So in this example, we have a stock solution of, let's say, sodium hydroxide, although the actual solution doesn't really matter. So let's call this a stock solution of sodium hydroxide. And in this solution, we have a concentration of 5 moles per liter. And the volume of our stock solution is 250 milliliters, or 0.250 liters. Now, I want to do what's called dilute this solution. So a dilution is when you take a stock solution and you typically transfer it to a larger volume and then add some more water to it. And remember that the sodium hydroxide solution is just solid sodium hydroxide dissolved in water. So if I take my solution here and I transfer it all into this larger 2-liter beaker, what's going to stay the same is the number of moles, because I can't create any new sodium hydroxide. So I still have the exact same amount of sodium hydroxide that I had before. What has changed, however, is now the amount of water. So I went from a 0.25 liter solution to a 2.0 liter solution. So the number of moles has stayed the same. We can figure out the original number of moles if we recall that N equals C times V. And that's going to give us a starting amount of 1.25 moles. So we have 1.25 moles of sodium hydroxide in our first solution, and all of that's going to be transferred into our second solution. We're not gaining or losing number of moles here. So we still are going to have N equals 1.25 moles. What will change is the concentration of the new solution. If we keep the same number of moles, but increase the volume, it makes sense that the concentration would have to decrease. So if we took a look here and we solved for the new concentration, which is number of moles divided by volume, the new concentration would be the 1.25 number of moles divided by 2 for the number of liters. That would leave us with 0.625 moles per liter. So a couple things that you should note will stay the same is the number of moles will stay the same. The volume, if the volume is increasing, which it is doing here, then you should note that the concentration is going to decrease. If the volume were to decrease, the concentration would, of course, increase. Now, is there a neater way to look at that? Well, we have this equation, which we're just going to kind of call our dilution equation, or the dilution formula. And it's a really easy way to compare the initial volumes and concentrations before you dilute to the final concentration and volumes after you dilute. So typically we'll say that C1 V1 is equal to C2 V2. And that means the initial concentration times the initial volume is going to be equal to the final concentration times the final volume. And the reason that this works is because the initial concentration times the initial volume is just the initial number of moles, and the final concentration times the final volume is the final number of moles. And like we said at the start, the number of moles is not going to change. So if I were to do this calculation with what was given to me, so let's just recall that we started with this concentration and this volume, and we also had the final volume. So if I were to actually do this calculation, I'm looking for what we're going to call C2, the final concentration. So a little bit of algebra allows me to rewrite the equation like this. which allows me to solve initial concentration, which was 5. Volume was 0.250, and the new volume was 2.00. You'll see that if you plug that into a calculator, you're going to be left with the exact same value that we came up with before by comparing it through moles. So the key here is to remember that the initial and final number of moles will always be the same. This is due obviously to things like the conservation of matter. We can't just create or destroy particles. And since we're transferring the entirety of the contents, stuff isn't just going to disappear. We can kind of take this question up a notch though and make it a little bit more difficult. So say you were asked a question along the lines of, let's say you had 500.0 milliliters of 6.5 molar sulfuric acid, which is H2SO4. And that is diluted down to 1.5 moles per liter. I'm going to change the question a little bit and ask you how much water was added. Note that I'm not asking you what is the new volume of water. What I'm asking you is how much water are we adding to this solution so that we get this correct final answer. So if you recall that what our equation was, let's first identify our variable. So this is the original volume. So that's just going to be our V1. This is our initial concentration. So we're going to call that C1. And this is our final concentration. So we're going to call that C2. So of course, we have the equation which we had just talked about before, where we said C1V1 equals C2V2. So the unknown in this case is going to be V2. I know everything else. So let's isolate for V2, rearrange my equation, and plug in everything I know. But just be aware that this is not going to give me the final answer I'm looking for yet. So I have 500.0 milliliters, so 0.5000 liters. I have a concentration of 6.5 moles per liter. And I have a final concentration of 1.5 moles per liter. You should be able to see here that the moles per liter will cancel and you're left with liters, which is of course the unit that you want. So this problem as it stands is going to leave me with a volume of 2,166.6 milliliters. If we're going to round to two significant figures, we can. We would leave it as 2,200. But for now, let's just, we'll round at the end. This is not the answer, though, that I'm looking for, because the question asks how much water was added. And to determine how much water was added, of course, we need to figure out how much water we started with and how much water we ended with. So how much water we added? Well, we ended with 2,166.6 milliliters. We started with 500.0 milliliters. And if you do this, it'll give you the amount of water you had to add so that you end up with the correct amount at the end. So this is 1,666.6 milliliters, but we're going to round to two significant figures. So 1,700 milliliters was added. So while you're still really asking the same question, the answer is a little bit different, right? Because I'm not actually looking for the final volume here. What I'm looking for is how do I get to that final volume? And a question like this really is more useful to us because when you're creating a solution in a lab, right, you need to know how much you're going to add to get to that final volume.